A new polar vortex is forming in the stratosphere over the North Pole and will bring its impact on winter weather for 2024-2025. A new polar vortex is developing in the stratosphere over the North Pole as nights get longer over the polar regions and temperatures drop. It is strengthening slower than usual this year, which could have weather implications during the winter of 2024-2025. The polar vortex has a long and strong history of winter weather impacts over the United States, Canada, and Europe, especially if it starts to collapse in the middle of the season, as seen a few times in the past years. We will first answer the questions like, what is the polar vortex and why do we monitor it so often? Then we will look at its current development and what its weaker early state in September tells us for the winter of 2024-2025 and a potential stratospheric warming event. Polar vortex over the north. Every year as we head into autumn, the polar regions start to cool. This is because the sun gets lower, and less energy reaches the North Pole. But as the polar temperatures drop, the atmosphere further to the south is still relatively warm. You can see the winter solstice in the image below. The polar regions receive little to zero solar energy compared to regions further south, which still receive plenty of sunlight and warmth. This causes a strong temperature difference between the polar and subtropical regions, which starts to create a large low-pressure, cyclonic, circulation across the northern hemisphere. It extends from the surface layers high up into the atmosphere. This is known as the polar vortex. The image below shows a three-dimensional image of the winter polar vortex. The vertical axis is greatly enhanced for better visual presentation. You can see the actual structure of the polar vortex, connecting down to the lower levels to the pressure systems. For this reason, we tend to separate the entire polar vortex into an upper, stratospheric, and a lower, tropospheric, part. They both play their role differently, so we monitor them separately. But it is also very important if they are properly connected. Image below by NOAA Climate. But, a very important thing to add. In this article and during winter, when we mention the word polar vortex, we, in most cases, refer to the higher stratospheric part of the polar vortex. It is very dynamic and packs a lot of power, and its changes can have a long-lasting effect. Polar vortex weather. The upper, stratospheric, part of the polar vortex is more circular and symmetrical as it spins higher above the ground. But the lower structure is much more uneven and wobbly. That is due to the influence of the terrain, mountains and strong pressure systems acting as obstacles in the flow. In the image below, you can see an example of the high-altitude polar vortex at around 30 kilometers, 18.5 miles in the middle stratosphere during winter. It is circular in shape, with the temperature dropping quickly towards its cold inner core. This is a rather text box example of a stratospheric polar vortex. The stronger winds are typically found in the outer edge, called the surf zone. Winds are important when describing the polar vortex, as they are usually the first to show that something is changing. In the next image below, we have the lower layers of the polar vortex at around 5 kilometers, 3 miles altitude. The closer to the ground we go, the more deformed the polar vortex gets. That is due to the influence of the terrain, mountains and strong pressure systems acting as obstacles around the northern hemisphere. Notice the cold arms, extending colder air and snowfall into the lower latitudes. These arms pack a lot of energy and can create strong winter storms and Arctic outbreaks across the United States and/or Europe. These cold arms can, in many cases, reflect what the upper, stratospheric, part of the polar vortex is doing. So, to summarize, the polar vortex is one large cyclonic area spinning over the entire northern hemisphere, from the ground up to the top of the stratosphere and beyond, reaching over 50 kilometers, 31 miles altitude. So the question arises, why do we care about the polar vortex every winter? The answer is actually quite simple. This stratospheric polar circulation called the polar vortex can mean the difference between a very cold and snowy winter and a warm and dry winter. A strong, stable polar vortex usually means strong polar circulation and jet stream. This contains the colder air into the Arctic Circle, creating milder conditions for most of the United States and Europe. In contrast, a weak, disrupted polar vortex creates a weak jet stream pattern. As a result, it has a harder time containing the cold air, which can now escape from the polar regions into the United States and Europe. Image by NOAA. So, if you are a fan of a warmer winter across the United States and Europe, you will prefer a strong polar vortex. But if you like proper winter weather with cold and snow, a weak, disrupted polar vortex is your best bet. As each year is different in the story of the polar vortex, we will look at the latest data in the stratosphere and how a new polar vortex is starting to emerge for the 2024-2025 winter season. New cold season, new polar vortex. The cooling over the North Pole has already begun. In the stratosphere, the cooling usually starts in August and increases strongly over September and October. Finally, the stratosphere reaches its coolest period in November and December, when the polar vortex is usually the strongest. Below is the NASA analysis graph for temperature in the mid-stratosphere over the North Pole. The blue line is last year, and the gray, white areas are historical data. The red square marks the month of September. The violet, orange line shows the latest analysis, forecast. You can see that the polar vortex is currently running colder than normal but at similar levels as last year, blue line. But at the end of the orange line, forecast, the temperature rises to normal levels. The temperature is dropping fast in the middle stratosphere at around 30 kilometers, 18.5 miles altitude. In the image below, you can see the temperature change forecast for late September. It shows ongoing cooling over and around the North Pole, with a strong temperature drop in the next 16 days. But notice an area of the stratosphere that is actually getting warmer. This is rather unusual for this time of year and is also why the NASA forecast shows the temperature graph rising to normal levels. Looking at the actual temperature forecast for late September, we can see a cold core developing over, around the polar circle in the stratosphere. This is the heart of the polar vortex, and the colder it gets, the stronger the polar vortex can become. But you can see an area of less cold temperatures over Siberia, defying the usual seasonal cooling. The pressure is also starting to drop rapidly. The image below shows the current geopotential height of 10 MB level, 30 kilometers, 18 miles altitude. You can see a smaller low pressure area that has already begun to develop over the Arctic Circle. That is the foundation for the polar vortex for the upcoming winter 2024-2025. Looking below at the forecast for late September, you can see the polar vortex is already more developed and rapidly increasing in size and influence. As the pressure drops in the polar vortex, it increases its wind speed and depth. The stronger it gets, the easier it can influence our weather down at the surface. To give you a better idea of how the polar vortex is developing, we produced a high-resolution video that shows the forecast data of the polar vortex growing in the stratosphere. Looking at the anomaly forecast for the same time and level, a high-pressure anomaly is developing over the Aleutians and into the North Pole. This will cause an early deformation of the stratospheric polar vortex and the stratospheric winds. Speaking of winds, the current forecast below shows the stratospheric jet stream developing. This is called the polar night jet. The image shows the stratospheric jet stream in the middle stratosphere at 10 MB level, 30 kilometers, 18 miles altitude. Usually, the stratospheric jet stream is more or less circular around the hemisphere. But this year, it shows an unusual shape due to the pressure and temperature anomalies around it. Winds in the stratosphere. The strength of the stratospheric jet stream at the 10 MB level is usually used to determine the strength of the polar vortex and its potential influence on the weather. This is especially the case during the midwinter when it is usually at its strongest. Compared to the long-term average, current forecasts show that the strength of the polar vortex will be below normal for the rest of September and into early October. That is seen in the image below, which shows the ECMWF forecast of the stratospheric polar vortex winds at 10 MB, approximately 30 kilometers, 18.5 miles. Red lines denote the average values. You can see the rest of September and early October marked in the black box. All the forecasts are below the average, showing that the polar vortex is running weaker than normal and will continue in this state for the coming weeks. Lower down in the atmosphere, we can still see these winds, called the jet stream. The image below shows the wind speed forecast for late September at around 5 kilometers, 3 miles, altitude. You can see the shape of the lower polar vortex, where we also have a weaker jet stream forecast. This shows that the overall weather circulation is connected on many levels and into a large single system. The reason for the weaker jet stream, both in the lower and upper parts of the polar vortex, is the high pressure anomaly found over the polar regions. You can see it in the image below, which shows the pressure anomaly forecast in the lower levels of the atmosphere, with the high pressure areas marked. The extended stratospheric forecast from ECMWF also shows a pretty interesting image, with the polar vortex being weaker than normal. In the image below we have the temperature anomaly forecast for the end of September. And you can see a large area of warm anomalies in the stratosphere over Siberia. Overall, this shows us that the stratospheric polar vortex will be weaker than normal over the whole of September and early October. But is this of any importance at all for winter 2024-2025? Weak polar vortex in September. This current situation in the stratosphere looks a bit unusual, so we decided to look at some monthly stratosphere data for each September in the past 44 years. The graph below shows which year had weaker, stronger winds in the stratosphere that month. You can see several years going into the negative values, which meant a weaker polar vortex in September. We decided to look at those years that really stand out with negative values, and the stratospheric anomalies in the following winter. First, looking at the stratosphere temperatures for January, February of the following season, we can see an interesting warm anomaly over the polar regions. This indicates a warmer, weaker polar vortex also in midwinter. Overall, the anomaly value is weak due to the different years mixed in this composite. But overall, it does show a higher potential for a weaker winter circulation following a weak stratospheric wind in September. If we look at the pressure anomalies for the same level of the stratosphere, we can see the same picture. A predominant high pressure anomaly over the pole that indicates a weaker polar vortex. This tells us an important story of how a weaker polar vortex in September can foreshadow a weaker polar vortex in winter. The values are not high or strong, but the signal it shows us is obvious. If we look at the overall context of these anomalies of temperature and pressure over the pole, we get a clear signature of a sudden stratospheric warming event, SSW. These high-energy events cause rapid temperature and pressure rises in the stratosphere, bringing about weather changes in the lower levels. Sudden stratospheric warming events. As mentioned, a sudden stratospheric warming event, SSW, is exactly what the name suggests. A sudden temperature rise in the polar stratosphere during winter. Warming of the stratosphere means that the polar vortex is weakened and can collapse under pressure from the warming event. A collapse of the stratospheric polar vortex creates a chain reaction, disrupting the jet stream below. This usually creates high pressure over the Arctic Circle and releases cold Arctic air into the United States or Europe. Such a textbook event occurred in February 2023, at least in most cases, but not all. Looking at the first day of that 2023 SSW event below, you can see a large warming wave in the top and mid-stratosphere. It spread over the polar regions. Combined with a stratospheric high, H, covering the North Pacific and Western Arctic, it has pushed and displaced the polar vortex, L, out of the North Pole. You can see the compressed polar vortex over Siberia, L. This is because a strong stratospheric high-pressure area, H, has taken over the polar regions and severely disrupted the atmospheric circulation in the higher and middle latitudes. The disruption happened on a large scale and extended over much of the stratosphere. Even though the disruption was strong, it still took time for actual effects to filter into the lower layers and our daily weather. The resulting pressure pattern below was fully established 2 weeks after the initial SSW event. The main result was a strong blocking high over Greenland, with the displaced low-pressure systems from the United States over the North Atlantic into northern Europe. This pressure pattern is a typical weak vortex event, and as we showed in the intro, it means an easier escape of cold air down into the lower latitudes. Looking at the temperature anomalies for that time, you can see a strong cold outbreak across the United States. The Greenland blocking system helps to push the cold air out of the polar regions, so a stratospheric warming event makes these scenarios much more likely in winter. There was no real cold air outbreak in Europe on a large scale, which also shows that a stratospheric warming event cannot always impact all regions with cold weather. Polar vortex and ENSO. One of the important large-scale factors for the upcoming winter season is also the La Niña event. This is a warm ocean anomaly in the tropical Pacific Ocean in a special region called the ENSO. We have discussed the new La Niña phase and its influence in our first winter forecast, so check it out for more details on the La Niña and the ENSO cycle. The cold phase of this cycle is called La Niña, and the warm phase is called El Niño. We are currently entering a new cold La Niña phase, being forecast to fully emerge in the coming weeks. Below is the ocean temperature forecast for late autumn and early winter from the NMME model. You can see a large area of cold anomalies over the tropical Pacific, which is the forecasted La Niña. It is expected to last over the winter of 2024-2025 and end in early spring. Historically, a La Niña winter has a 60 to 75% chance of producing a stratospheric warming event, SSW. It has produced them in the past and also in recent winters. The image below shows the typical SSW event frequency by month and by the ENSO event. As you can see, a La Niña phase has a higher chance of producing a polar vortex collapse event. It also produces one a bit later in winter, compared to an El Niño. Overall, this means that a La Niña event is unfavorable for a strong polar vortex, at least on average. Below is an image that shows typical winter pressure anomalies over the Western Hemisphere for each ENSO phase. The third example shows the best pressure pattern to weaken the polar vortex and start a warming event in the stratosphere. As you can see, the typical La Niña pattern is overall a bit more favorable for a weakening event of the polar vortex, with low pressure over the Aleutians. This means that it can be easier for winter weather patterns to be disrupted and bring colder weather and snow to the United States and Europe. This is just an additional factor that currently hints at the potential of a weaker winter circulation. As you can see, a strong or weak polar vortex can significantly change winter weather in the United States, Canada, and Europe. But the polar vortex is not a simple thing to forecast, as it depends on many small and large-scale factors.